So let's dive right in here. The first question I'm going to go over is, it says, what is the y-coordinate of the y-intercept of the graph of 3x over 7 equals negative 5y over 9 plus 21 in the x-plane, xy plane. Okay, so when they say, as soon as you see that they say the words x, y, or they say the y-coordinate of, and they say the y-intercept, what do you think when you have y-intercept? You've got to remember that the x-coordinate is going to be 0. Whatever the y-intercept is, the x-coordinate has to be 0. So let's go ahead and do that in this equation they give us. So what I mean is, in the equation up here, if we write 0 for x, so I'm going to go 3 parentheses 0 over the 7 will equal the negative of 5y over 9 plus 21. That, of course, will cancel that whole term out. So if I add the 5y, this negative 5y over 9, if I add it and bring it over to the other side of the equation, you're going to have 5y over 9 is going to equal 21. Now, when I cross multiply, multiplying both sides by 9, I end up getting 5y is equal to 189. Dividing by 5, we get y is equal to 189 over 5. That is the answer, 189 over 5, or you can also grid that in as a decimal. It comes out to be 37.8. Either one is acceptable. So again, if you see the y-intercept, if they say y-intercept, immediately think right away, okay, x is 0. The next one is a quadratic, a parabola, and knowing the standard form of the equation. So the standard form of the equation, you always want to remember, is y is equal to, we use ax squared plus bx plus c, of course. All right. And then in this picture, they're giving us the graph, the y equals 2x squared plus bx plus c. So they've actually given us one of the coefficients, the a value. So we know that's 2. We still don't know what b is, and we don't know what c is. And in fact, they're asking what is the value of b times c. Now, notice they'll say where b and c are constants. Whenever you see the word constants, if it says constants, immediately you should remind yourself that a constant, that's an actual number. They're just not showing it to us. You know, they have some quadratic in mind here, but they're hiding what those coefficients b, the coefficient b is, a coefficient of x, and then the constant c. Both of those numbers right now are constant, meaning they're a number that doesn't change, they're just not showing it to you. So we need to figure out what b and c are. Here's where you're going to want to use your knowledge that in a parabola or a quadratic, the vertex is, well, first of all, our vertex we always call the x-coordinate h and the y-coordinate k. The vertex for h will always be equal to the negative or the opposite of whatever b is over 2 times a. So negative b over 2 times a. Well, in this one, we see that the x-coordinate is lining up. It looks like it's a negative 1. So that h value, so we have a vertex that's negative 1, and actually we can see down there the y-coordinate is negative 8. So, but our h, or the x-coordinate of the vertex, is the negative 1. So if negative b over 2a equals negative 1, and I just multiply by 2a over here, you get negative b equals negative 2a. Dividing both sides by negative, you're going to get negatives are going to go away. So you're basically going to have b equals 2a. Well, we know what a is, right? A is the 2 right here. So we can multiply that 2 I had here times the a, which is 2. 2 times 2, we get 4. Okay, so we know that b is equal to 4. C. Okay, C. C is when we have the standard form of the equation, and you have talking about C. C is, imagine if x is 0. Okay, so right here, if I said if x equals 0 in this this graph, well, that would mean I'd be on the y-axis, right? And therefore, the y-coordinate corresponding to that is a -6. So y would be -6. So if I plug in 0 into this equation up here, you would get y equals 2 times 0 squared. So that's gone. Plus, it doesn't even matter what b is. Put a 0, that's gone. So y would equal -6. That means that this c value is the -6. Because when I put in 0 for x, the y we know is -6. Therefore, I know the c value is -6. So we know that c is -6, and I can multiply those to get -24. And that's the answer for this one. So 22 is a percent problem. Gotta practice percent problems. There's so many ways they can ask you this, and always is a weakness, even for the best scorers. There's just not enough practice in school with percents. So in this one, it says 2008, Zyna earned 14% more than in 2007. And then in 2009, earned 4% more than 2008. So I like to do this out as a visual. So what I'm going to do is I'm going to say in 2008, we had so 2008 is, actually I probably would want to just go like this. If I'm going to have 3 years, why don't I just do, I'm going to have, there was 2007, that's my starting year. Then I go to 2008, then I go to 2009. And it says that in 2007, we don't, oh, here's the other thing to point out. When you see any percent problem that does not have an actual number, then you need to sub in, pretend that the number is 100. So here's what I mean. This just says that Zyna earned 14% more in 2008 than in 2007, and then earned 4% more than in 2008. Earned y times as much. Okay, there's no given amount. It doesn't say that Zyna started with 348. It doesn't say that Zyna ended up with 6,418. There's no actual number. There's just percents. So what you want to do here is pretend or just say that the amount earned in 2007, let's say we call that $100. Okay, so $100, I'm going to put a 100 here. I don't need to put the dollars, I'll just put 100. So it says then that in 2008, Zyna earned 14% more than that 100. So going to the next year, we added 14%. Because I used 100 as an example, it's easy to calculate 14% of 100 is 14. So I'm actually adding $14. That means in 2008, Zyna would have 114. Now it says from 2008 to 2009, this is a 4% gain. So plus 4%. So of course, 4%, 0.04 times, I'm sitting at 114. So when I do that, that's a gain of, that comes out to be 4.56 on my calculator. So I'm actually adding 4.56 to this 114 up here. And that means that I end up with 118.56. So, and then the question asks, okay, how many times, so Zyna earned y times as much in 2000 as 2007. What is the value of y? So they're comparing 2009 to 2007. How many times bigger was 2009? Okay, well 2009 in my example came out to be 118.56. And for 2007 I had used the 100. So you can see that 118.56 compared to 100 is, well, dividing by 100, I'm just going to move the decimal point 2 places, That means it's 1.1856 times as big as it was to start. So the answer is D. In this circle, they're saying that the equation is x plus 2 squared. Right? So when we have the plus 2 there, because the equation says x minus h, that means if it were plus 2 in here, then h had to be a negative 2. And then here, when they don't have a parentheses, they just have y squared, that means that k was equal to 0. And you can see that the center is at negative 2, 0 on the graph. Then the radius, so they give the equation that this equals 9. Therefore, you know that the radius is only 3. Now, that's circle A. For circle B, they're going to shift the circle down 6 units. That means that just the y-coordinate of the center, or the k value, is going to go from 0. I'm going to subtract 6, so it's going to be at negative 6. The h value, the x-coordinate of the center, is not going to change. So when I have my equation, they're giving me choices for the equation. I'm still going to have this x plus 2 in parentheses squared. And then you're going to have, instead of the y squared I had before, I'm going to go plus y. And remember, since the formula is y minus k, if I'm going to be a k value of negative 6, this. So for 24, we've got a right triangle with a hypotenuse of 54 and a 30-degree angle at angle B. And they want the value of tan A. So again, you're going to want to make sure you know your SOHCAHTOA, right? So tangent of any angle is going to equal your opposite side over your adjacent, right? So they want, be careful here. Sometimes people can mess this up. They do list angle 30, but they want the tangent of A. So the opposite side is over here. The problem is I don't have either of those sides. And I only have the hypotenuse, so I can't use Pythagorean theorem. So here we have 30-degree angles. Of course, this is going to mean we need to use our 30, 60, 90 triangles. Now, you should know these anyway, but if you don't remember them, they are actually on the beginning of the section. They'll tell you the ratio. So if this is a 30-degree here, and this is the 60, then we know this is x, and then this is 2 times x, and here is x root of 3. So we've got opposite of 30 is the x, that's going to be half of the hypotenuse here. Therefore, in our situation, I'm going to have half of 54 is going to be 27, that's going to go there. And then we take that, so the opposite of 60 is that x times square root of 3. So I'm going to have this 27. For 25, here's a longly worded question. And it's going to have to do with exponential growth, another thing that stumps a lot of people. So the question reads, at the time an article was first featured, there's 40 comments on an article. So we've got an exponential model estimates that at the end of each hour if the article was first featured, the number of comments in the article had increased by 190% of the numbers at the end of the previous hour. Which of the following equations can represent this? So C is the estimated number, basically the ending amount, and then this is, and T is the hours. So this is these are typical exponential models, and they should look very familiar, right? Because in our exponential models, our basic model is we have a final amount, so I'll put F for the subscript there, will equal an amount original, then some kind of growth rate or decay. And the basic model says 1 plus, or it could be minus, but in this case we know that it's growing, so I'm just going to stick with the plus. R value goes there, and then to the time. So what is the R value? The R value is going to be the percent, in this case, increase, the percent that it goes up. And we're going to need to have that in decimal form. So 190% is the increase. So This can be tricky because at first glance, someone might say, okay, yeah, I got the final amount's going to equal the 40. Well, they all have that choice, right? And then if it's a 190% increase, then choice B may look very promising here, where if I put 1.9, because, well, we know that 190% as a decimal is 1.9. So a lot of people will go for that one because it's saying 190% increase. However, that's not correct because it's an increase of 190%. So let me give you an example. Let's say something is increasing by, let's say we had something increasing by 10%. All right, so let's say you have, it had increased by 10% if it had gone up by that. So my R in this model right there, R would be the decimal form of 10% or 0.1 or 0.10, however you want to look at it. Because then I would have the 40, and then if it were up by 10% each time, I would do the 1 plus my R, which I'm saying for a moment is that, and that comes out to be 1.1. This would be to the T. Okay, so what does that show me? When I have a 1.1 in the parentheses, that showed me a 1% increase. Okay, because it was 1, we already always have to have the 1 right here. So I had the 1 plus the R. Okay, what is my R in this 190% situation? The R, well, the rate is 190% increase. That means as a decimal, the R value is 1.9, as I said. So in your model, you really have to have, well, in this case, they're using C equals the 40. And we do 1 plus the R, which is 1.9. That means that in the parentheses, it is 2.9, not 1.9. And that's to the power of T. So that is why the correct answer is not 1.9, it is 2.9, so the answer is D. 26, we're talking about some functions here. We've got a g of x and an f of x. Okay, so I've got x is negative 27, so I'm going to put in a negative 27 for this x. Negative 27 plus 3. And I'm still leaving f of x up there because I don't know what it is. But the g of x value when x is negative 27, that was this 3. So I'll put in a 3 for that. That is equal to 3. And then simplifying down here, negative 27 plus 3, you get a negative 24. So if I multiply both sides by negative 24, over here I'm getting 3 times negative 24. So we get a negative 72 is equal to f of x. Okay? When we get, so now we know that, what does that mean? That means that when x is, what I put in negative 27. So when x equaled negative 27, the f of x was the negative 72. So f of x, remember the f of x is really this some line, which we're trying to figure that out. So so f of x is like the y. It's like the y here. So on this line, we know if you say y is equal to negative 72 when x is negative 27, that means I have a coordinate. That means that negative 27 comma negative 72 is a coordinate on this f line. But to figure out what the equation of a line is, you need 2 points. So let's do the same process again, but this time we're going to plug in, we can go with plugging in a negative 9 for x, and then g of x is 0. So the equation was g of x equals, so 0 equals the f of x over, and I'm plugging in -9 for x plus the 3. That's going to mean that I've got 0 equals f of x over -6. Well, when I multiply both sides by -6, of course there's a 0 here, so it turns out f of x comes out to be over, finding the change in x, the first coordinate, we call this, well, this was x2 right here. I said -9 is x2, so I need to do, this is over -9, take away, and the first x was -27. So that's really -9 plus 27, so that's over an 18, so that is a slope of 4. So I've got my slope, but I need the equation because they want the y-intercept, so I need to be able to find the equation. Well, if you have the slope of 4, and you can use either coordinate, I just use the model. Let's go y equals mx plus b, and then, all right, so I know the slope is 4. So this is going to be a 4. And I have a sample x and y coordinate right here because I can use -9, 0 right there. So let me just do that. Let me plug in -9 for x, and then I got a 0 for y when I do that because that's the y coordinate. But what I don't know is I don't know b. What does b come out to be? So this is a 4 times -9, you get a -36. So we end up getting a 0 is equal to -36. So for the last one here, they give you a right triangle. And so I'm going to immediately just sketch a right triangle. So I've got, let's just do a right triangle here. And something like that. Okay, and then they say that it's ABC, so I'll label the points ABC, so go, oh wait, yeah, so C is a right angle, so I've got to make sure I put that there. C is going to be my right angle. It doesn't matter where I put A and B. Okay, so point D, so point C is a right angle, point D on side AB. Oh, and BC is 162. So I'm going to want to put that in 162 down here. Okay. Now it's saying that point D is on side AB, all right, somewhere on the hypotenuse. And it's connected by a line segment with point E. So we've got point D on AB and point E on side AC. All right. So let me put D on AB. So somewhere in here, this could be a point like right here, and I'll call that D. And then they're connecting to some side, some point E on side EC, but where do I put it? Oh, so that means, and they're saying that line DE that I'm drawing is parallel to this BC down here. Okay, so that means it has to go pretty much just straight across here to be parallel. And then this right here, this one was labeled E. Okay, so now what I've got is they're saying that, so this looks like it's going to be a similar triangle problem. We've got a triangle within another triangle. So they say then that BC, CE is double AE. CE is double AE. So this right here, this CE, that is double this. The way I want to represent that is I'm going to call that this AE distance x, and then this is 2x. What is the length of DE is what they want to know. So what you want to do here is you want to break this into just some geometry, break it into 2 separate triangles. I'm going to have the little one on top. And then I'm going to draw the bigger one, the whole thing. do that down here. Just make it a little bit bigger. So now what I've got is I've got to put my variable in here. So this top one represents, this is going to be the x, because this is the triangle AED right up here. So that represents this side. Then notice though, the whole triangle from A to C all the way to B, this isn't just the 2x, this is this whole thing, 2x plus x. So this has to be a 3x on this side. So you can see that the bigger triangle is 3 times the size of the little triangle. Therefore, if this is 162, that's the whole thing, the whole triangle base down there. This right here is what we're looking for. We're looking for ED. So this is where I'm going to do a proportion. I know that in the smaller triangle, x was to the 3x. Then you do proportion as ED, that's the smaller triangle side, is to the corresponding side in the bigger triangle, which was 162. Okay, so when I actually cross multiply that, you get the 162x is equal to 3x times ED, but you also could just figure out, so then I would just divide both sides by 3x and by 3x. Or you could have just said, okay, I know that, and then that this number is 3 times ED. So I could really end up doing is 162 divided by 3, and that's going to equal 54. Now, checking what they're asking, they're saying, what is the length of segment ED or DE? That's the answer, is 54. So hopefully you've gotten through these problems and have a better understanding of how to solve them. I suggest sometime in the future waiting till you've kind of forgotten what we did and then try them again on your own, and then you can see how I explained them. It's okay, just keep reusing them as long as you're having space in between where you forget them but then you redo them. Okay, don't think it's like, okay, I already did that problem a week ago or 2 weeks ago, I'm not going to do it again. Thing is, you're not going to necessarily remember it, so keep practicing the same ones, okay? Because again, I'm trying to make as many as I can here that are challenging, but you're eventually going to run out, so just keep reusing them and I'll keep adding more.